how would you use convex mirror as a side? Why? Sorry, it's why would you use a convex mirror as a side and rear view mirror of cars? Why? Why would you use convex mirror for that purpose? Anybody? Why would you use a convex mirror as a side view and rear view mirror of cars? Ella Davis, why would you use a convex mirror as side view and rear view mirror of cars? Why? Hey, anybody?
Okay, say maybe it's because they have a wide field of view, like they are flat surfaces.
Exactly. One, because convex mirror has a wider field of view or angle of view. That is one. Francis, go ahead.
Objects appear smaller but cover a large area in the mirror.
That's a field of view. That's a field of view. Saki.
So I was going to say the same thing, that
Yasmin. Okay, Yasmin.
Yeah, because the image is upright.
Always upright or erect, no matter the object position. So these are the two main reasons why. Michelle. Michelle, I'm listening. We are listening, Michelle.
The comments, please, can you hear me?
Michelle, I can hear you.
Hello?
Hello, Michelle. We are listening.
Okay. Please, the convex mirror scatter reflected light, thus reducing the glare from the headlights of the vehicles behind it.
Okay. That's also an elaborate point. Okay, so I have a couple of them. Let's quickly go through. Please put this question down. Two mirrors are inclined to each other. Two mirrors are inclined to each other at 90 degrees. Two mirrors are inclined to each other at 90 degrees. If a ray of light is incident on one of them, if a ray of light is incident on one of them at a glancing angle of 48 degrees, determine the angle of deviation. Determine the angle of deviation with respect to the second mirror. Determine the angle of deviation with respect to the second mirror. I'm going over. Two mirrors are inclined to each other at an angle of 90 degrees. If a ray of light is incident on one of them at a glancing angle of 48 degrees, determine the angle of deviation with respect to the second mirror. 5 minutes. 5 minutes.
I didn't quite.
Two mirrors are inclined to each other at an angle of 90 degrees. If a ray of light is incident on one of them at a glancing angle of 48 degrees, determine the angle of deviation with respect to the second mirror. Determine the angle of deviation with respect to the second mirror. So 5 minutes. Start work.
Sir,
Gideon,
please can you read the question again? Sir,
please listen attentively. Two mirrors are inclined to each other at an angle of 90 degrees. At an angle of 90 degrees. If a ray of light is incident on one of them at a glancing angle of 48 degrees, determine the angle of deviation with respect to the second mirror. Determine the angle of deviation with respect to the second mirror.
So please, how are
please
we
can you take
supposed
the
to know
glass?
which one is mirror one or mirror two?
Pardon?
Please, how are we supposed to know which of them is mirror one or mirror two?
No, it can be any. It can be any one of them. Okay, that's why I said it is the if a ray of light is incident on one of them at a glancing angle of 48, it can be any one of them. Are you okay?
Yes, please.
Your 5 minutes is still counting, oh.
So we should determine the
Eh?
so
Determine
we
that.
should determine the
Yeah, you Gideon, listen attentively. Determine the angle of deviation with respect to the second mirror. Determine the angle of deviation with respect to the second mirror. Somebody is giving me 96. We shall see. Isaac, don't worry. You still have the chance to solve it, okay? So go ahead. You have about 3 minutes. Somebody is giving me 84. Somebody by name Yasmin is giving me 84. Yasmin, we shall see. Stephen is giving me 82. Ohene, 84. Francis, 96. You have 2 minutes to go. Ablina is giving me 84. Okay, your time is up. Let's see. Let's see. So let me share the whiteboard. Okay, so two mirrors are inclined to each other at 90. So let me sketch these two mirrors. Mirror 1, mirror 2. The angle between them is 90. Something to show that it's a mirror. So light, if a ray of light is incident on one of them at a glancing angle, so I am incidenting the ray here, meaning this is the glancing angle. And I'm told that the glancing angle is 48. Okay, so once the ray incident on the mirror, it will reflect. So this is a reflected. And will also reflect again. So there's a reflection with respect to the second mirror. So incident, reflected, and then reflection as a result of the second one. My normal is here with respect to the first mirror. Another normal I'm coming. Good. So if this is 48, this is 90 minus 48. And what is 90 minus 48? 42. This is also 42 degree. This will be 48 as well. Once this is 48, this is 90. What will be this angle? What will be this angle? 90 plus 48. Oh, hurry up, hurry up.
138.
So subtract that from 180.
42 degrees.
Come again.
42 degrees.
Okay, this is also 42. If this is 42, this is also 90 minus 42. This is 48. 48. And this is 42 degrees. So the question asks that we are to determine the angle of deviation with respect to the second mirror. Okay. So ideally, this ray here is supposed to just go straight, but because of the mirror, it did not. So how do we determine that angle, this whole angle? How do we determine this whole angle? This is a Hesaki.
180 degrees minus 2i.
So the angle of deviation is 180 degree minus 2i, and I is 48. Okay, I is 48. So 180 minus 48 times 2. What is 48 times 2?
96.
96.
So subtract 96 from 180.
84.
That is 84 degree. So that's the answer to the question. All right, another question. Today we are basically solving. I have standardized test questions from GEHE. And so we are quickly going through it. An object is situated 25 centimeter. An object is situated 25 centimeter from a concave mirror of radius of curvature 60. I'm coming. From a concave mirror of radius of curvature 60 centimeter. Determine I. Determine I the image position. Determine I the image position. I. The nature of the image. I. The nature of the image. I. The magnification. I. The magnification. And IV. The height of the image if the object is 30 centimeter in height. IV. The height of the image if the object is 30 centimeter in height. So I'm going over. An object is situated 25 centimeter from a concave mirror of radius of curvature 60 centimeter. Determine I, the image position. I, the nature of the image. I, the magnification. And IV, the height of the image if the object is 30 centimeter in height. Start work. This will be 8 minutes. It's 3:54. 6 minutes more. We have done 5 minutes. One minute more. 1 minute. Okay, time is up. We have other things, a lot of questions to answer. So an object is situated 25 centimeters from a concave mirror. So straight away, object distance US 25 centimeters. The radius of curvature is 60. Determine I, the image position. And when we finish, the nature of the image. Okay. So if R is 60, because R is equal to 2 times F, it means F would be equal to 60 divided by 2, which is 30 centimeters. So that is the focal length of the concave mirror. So using RP convention, so you must state the convention you are using. Using RP convention, RP, anything real is positive. If it's virtual, it's negative. Okay. So 1 on F is equal to 1 on U plus 1 on V. Okay, we for concave mirror, F principal focus is real, so F is positive. So 1 over 30 is equal to 1 over 25. Object is also real, plus 1 on V. Now, before we even continue, we can compare U and V to determine the nature of the image. Okay, U is less than F. F is 30, U is 25. So it means U is less than F. And because object distance is less than the focal length, it means the image will be virtual. So when we make V the sub, 1 over V is equal to 1 over 30 minus 1 on 25. What's the LCM? 30 and 25. What's the LCM?
150.
150.
150. 30 goes into 150 how many times? 30 goes into
5.
so
5.
okay, so 1 remainder 5. So 5 times that minus 25 into 151 remainder what? Remainder what? 25 into 150.
6.
6.
No
Okay.
remainder.
So
Remainder.
okay, so 6. Okay, so we have okay, no remainder rather. Okay, so 1 on V is equal to negative 1 on 150. V is equal to negative 150. Okay, and once V is negative, it means that image is virtual, RP. Anything real is positive, anything virtual is okay. So that will be the image distance, meaning that the image will be 150 centimeters from the concave mirror, but it will occur at the other side behind the mirror. Okay, so the magnitude of the image or the image position will be 150 centimeters from the mirror, but it will occur behind the mirror or opposite to the object. That's why it's negative. All right. Then the nature of the image. The nature of the image, we have answered that. Because object distance, or even because V is negative, image will be virtual. Image is virtual. Okay. Then the third question, the magnification. The magnitude of the linear magnification is V over U. V is 150, U is 25. What is 150 divided by 25?
6.
6.
So it will be magnified because this value is greater than 1. Image, that's the magnification. The image will be magnified 6 times as the object. The height of the image, if the object is 30 centimeters in height, So magnitude of magnification, the linear magnification M, is V over U is equal to HI on HO. V is 150. Please, not negative 150. No, the magnitude. That's why I have this symbol here. So we are using numerical value. So 150 divided by 25 is equal to image height, which we are looking for, divided by object height, which is, so we are to calculate that if the height of the, okay. We are to determine the height of the image if the object is 30 centimeter. So HO is 30 centimeter. Therefore, make.
So please, I have a question.
Okay, Bashira.
Sir, please, why didn't you let the M be -6?
Good. You see, I did not use the negative because of this symbol. We are looking at, you see, magnification is just whether the ratio is greater than 1, less than 1, or equal to 1. If M, small letter m, is equal to 1, then it means that image size is equal to object size. If m is greater than 1, it means the image will be magnified. If m is less than 1, image will be there. So we are looking at numerical value. That is why we use this symbol. Okay, magnitude, we put small letter m within the absolute value symbol. Okay, it is of that reason that we didn't consider negative 150 divided by 25. We considered the numerical value. V being equal to negative 150 does not mean the number is lesser, but all that it means is that the image appears at a distance of 150 behind the mirror. The negative simply means behind the mirror. Bashir, are you okay?
Yes, please.
So it's a numerical thing. Edmond.
Yes, sir. Sir, please, I have a question.
Go quick.
The concave mirror. I thought you said using. Okay. I see now. Sorry, sir.
All right. Okay, so what is okay, 5 will go into this 5 will go into this 6. So please multiply that for me. Okay, 5 would also go into 150. That's 30. So 6 times 30. That's 180. Good. So the image height would also be 180 centimeter. Andy.
So please, why didn't you just go straight away to use like the magnification is 6, so you just magnification is equal to.
We can also do that. Yes, we can also do that. V over U is 6, so 6 is equal to HI over 30, and HI would equal to 180. This is even simple, but because we are learning, that's why we are considering all options. I think that's a good point to note. All right. Another question. What is refraction of light? Can somebody help? What is refraction of light? Gideon.
So this refraction of light is the bending nature of light.
Gideon, when you say that you get coins of maths, you will not get notes. Frank.
Can I add something to the definition?
You must add.
Okay. So this is the bending nature of light. When light moves from a more dense medium to a less dense medium.
No.
Or from a less
okay.
more dense
So
medium.
So put them together. when light from one medium into another medium of different optical densities. So here it doesn't matter if it's moving from more into less or less into more. Simply the bending of light as it moves from one medium into another of different optical densities. Frank.
Sir, please, can you add resulting in the change of direction of light, the change of wavelength, and the change of speed of light?
No. Say it. Okay, you can explain refraction using any of these three. Change in direction of light from one medium to another of different optical densities, or change in the speed of light as it moves from one medium to another of different densities, or change in the wavelength of light. Are you okay?
Yes, sir.
All right. Okay, this one, I think you can, the question is saying that draw a ray diagram to show how a concave mirror forms a real image, and two, to show how a concave mirror forms a virtual image. I'll do that for you. So draw a ray diagram to show how a concave mirror forms A, real image, and B, a virtual image. So let's assume this is a concave mirror. What shows that it's concave? I must coat the outer side. This is the pole. This is the principal axis. F is here. Please don't forget that you must take measurements. And this is C. Any other position, any position apart from being between P and F will give you a real image. So here you can place it. So there's a head of the object. So O to indicate the object. A ray from the object hitting the mirror will be reflected. The refracted ray will pass through F. A ray of light from the object passing through F after hitting the mirror must travel parallel to it. And the reflected ray must be parallel to it. Okay, what shows that these are rays? Arrows. I saw those mistakes yesterday. Whenever you are drawing a ray, the arrow is very, very important. So where the reflected rays meet is the head of the image. So this is the object. So that is how a concave mirror forms a real image. A virtual image, the same concave mirror, the pole is here. So F, take measurement, please. So C is here, F is here. For virtual image, the object must be in between P and F. So rays from the object in that parallel manner after reflection must pass through F. The network is disturbing my drawings. Good. So a ray of light passing through C must hit the mirror at 90. And when that happens, we have the incident, the reflected. And look at the two reflected rays, this one and then this one. There's no way they will ever meet in front here. So we extend the rays at the back of the mirror where they appear to meet. A virtual image will be formed behind the mirror. So the rays appear to meet over here. And this will be the image, meaning that we must extend the principal axis at the back of the mirror. So that's it. We've done this severally. So Gideon.
So can you conclude that all real images are formed behind the principal focus and all virtual images are formed in front of the principal focus?
The conclusion, all real images are in front of the mirror and virtual images are behind the mirror. That's how you must conclude. Frank.
I was saying a different thing. I was asking if you can also conclude that for a real image to be formed, the object must be behind the principal focus. And for a virtual image to be formed, the object must be in front of the principal focus. That's what I was asking.
No, object is always, you see, no, Gideon, we've gone through this. For real images, the only time concave mirror forms a virtual image is when the object is between the pole and F. All other positions, it must be real. So look at the object. Once the object appears between the pole and F, the image will be virtual. All other positioning must be real. Frank.
Sir, please, if you use the line that reflects of the principal focus, will you get the same image height?
You won't get the same image height, but it will still be magnified compared to the object.
Okay, sir.
Yes, the height will not be the same, but it will be same. It will be magnified image. Okay, please put this question down. Light passes from air into a liquid. Light passes from air into a liquid and is deviated by 19 degrees and is deviated by 19 degrees when the angle of incidence is 52 degrees. When the angle of incidence is 52 degrees. What is the index of refraction of the liquid? I'm going over the question. Please listen attentively. Light passes from air into a liquid and is deviated by 19 degrees when the angle of incidence is 52 degrees. When the angle of incidence is 52 degrees. What is the index of refraction of the liquid? What is the index of refraction of the liquid? Start with 6 minutes. It's 4:23. 4:23. You look through it again. Isabella, okay. but I'll look through it again. Light passes from air into a liquid. So just a quick sketch. This is the normal. Liquid. So light passes from air into a liquid and is deviated through 19 degrees when the angle of incidence is 52. So if this is the normal, this is 52. Once it is moving from air to liquid, it will bend towards the normal. This is the refracted ray. And so this is the angle of refraction R. When we extend the incident ray, it will give us the extent to which it will give us the angle of deviation. And by vertically opposite angle raising, incidence ray I, angle of incidence I is equal to angle of refraction plus the angle of deviation. Okay, our angle of refraction is equal to angle of incidence minus angle of deviation. Angle of incidence 52, angle of deviation 19. What is 52 minus 19?
33.
33.
Okay, so the angle of refraction is 33 degrees. Therefore, using Snell's law, absolute refractive index of the liquid is sine of I over, look at how my handwriting is being exchanged for something else. Sine I over sine R. So we have sine of 52 divided by sine of 33. Class, what is sine 52 divided by sine 33?
1.45.
So 1.45 is the refractive index of the liquid. Let me see by hands those of you who got this correct. If you got this answer correct, let me see you. Bashira got it. Ella got it. Anita, Blessing, Abenema, Kusia. Oh, okay. Angie. Oh, okay. That's awesome. Okay. So this is the problem of the day. Okay. I remember, in fact, I took you through deviation in anti-refraction. I remember I took you through deviation. We did this. So that is what you must apply in solving this problem. Is there any question? Michaela, your hand is still up. What is your secret? Okay. So that's it. As I told you yesterday, I will have another section with you before I leave you alone. Okay, so that will be either Saturday evening or or Friday evening. I'll update you. But in the meantime, in fact, you must appraise me, students' appraiser of their teacher. So I'm going to share the appraisal form with you so that we go through it. Okay. Hello, is that clear?
Yes,
Yes,
please.
sir.
Yes, please.
Okay, so it's on the platform. I've just posted it onto our physics platform. Please tap on it and let's do this together. Tap on it and let's go through it together. So Omega teacher evaluation form. Evaluation form on your physics teacher. This is the day of reckoning by students. So dear students, management of Omega Education Council wishes to seek feedback from you to strengthen the quality of teaching and learning. The purpose is to improve teachers' performance in online engagement with students to bring excellent appreciation of topics taught. Please be assured that all responses will be kept completely confidential. 1. Links to joining the class are shared before the scheduled start time. Okay, so A, never shared before time. B, sometimes shared late. C, often shared late. And D, always shared before time. So pick the right one, the very option which is applicable to me. 2, does the teacher skip classes? A, skips class most of the time. B, skips class sometimes. C, never skips class. So pick the one which you think is applicable. Give the number of times 3. Give the number of times the teacher has skipped classes from A up to E. 0, 1, 2, 3, blah, blah, blah. Pick 4. Teacher makes alternative arrangements. If he or she is unable to attend class, A, never makes any alternative arrangement. B, sometimes makes alternative arrangement. And C, has never skipped class. 5, teacher is willing to answer your questions privately after lessons. A, never answers my questions privately. B, ignores my private questions. C, sometimes answers my private questions. D, always answers my private questions. Sex. Are reasons given for not answering your questions privately? A, no reasons given. B, sometimes reasons are given. C, yes, reasons are always given. And D, not applicable. 7. Teacher's voice is very clear during class session. A, voice is always low. B, voice is sometimes clear, other times not clear. C, voice is most of the time clear. D, voice is clear at all times throughout the lesson. 8. How clear are writings and illustrations on board and screens? A, writing is not clear, it is difficult to read. B, handwriting is sometimes not clear. C, handwriting is clear at all times. 9. Background of the teacher during lesson is A, always noisy and disruptive. B, sometimes noisy. C, always quiet throughout the lesson. 10. The teacher gives assignment on topics taught. A, never gives assignment. B, occasionally gives assignment. C, often gives assignment. And D, always gives assignment. 11. Teacher marks assignment promptly and gives feedback for improvements. A, never marks assignment given. B, occasionally marks assignment given. C, marks some and leaves others. D, always marks and gives feedback for improvement. 12. How many exercises, tests, assignments, homeworks, or group works, etc. have been given by the teacher? So we have A to F. Okay, pick what you think is applicable to me. 13. My level of understanding of what is taught is A, I do not understand most of the time. B, I understand some of the concepts. C, I understand most of the concepts. D, I have excellent understanding of all concepts. Yeah, pick what is applicable to you, not me, to you. 14. Are videos of lessons shared with you? A, never shares videos on lessons. B, sometimes shares videos. And C, shares videos on all lessons. 15. Rates the stability of teachers' internet connectivity. A, connectivity is always bad. B, network drops too frequently. C, network drops occasionally. And D, network is consistently stable throughout the lesson. 16. The method used in the lesson delivery is A, less interactive. B, quite interactive. C, very interactive. And D, excellently interactive. 17. Will you like to maintain your teacher? A, no, I wish I have a different teacher. B, maybe. C, yes, I will always like him or her to teach me. Then 18. I will join Omega vacation classes in my next vacation holidays. A, no, I will not join Omega. B, I am not sure if I will join Omega. C, yes, I will definitely join Omega. In fact, you must join Omega. We are adverts. 19. Did the teacher meet your expectations? A, no, my expectations were not met at all. B, yes, my expectations were met to a large extent. And D, yes, my expectations were excellently met. 20. Any other comments about the teacher? I'll give you some time to do that here, about 2 minutes. Any other comments about the teacher? About 2-3 minutes to do that, since you'll be typing. If you finish, please let me know so we can move on. Can we continue? Can we continue to 21?
Yes, please.
All right. Any other comment for Omega management? Any other comment for Omega management? If you have some comment for Omega management, write something for us. Please, when you finish, do not forget to submit. Hit on the submit button. Else, all that you have done earlier will be cost 90, which is 0. So when you finish, press on the submit button. If you don't submit, you have not submitted anything. Class, is everyone through? Are we all through with the evaluation?
Yes, please.
Let me hear yes from all homes and
Yes,
all
please.
locations.
Yes, please.
Yes.
Okay. All right. Thanks so much for the evaluation, but I'm not done with you. Listen to this question. Listen to this question. A ray on the principal axis is reflected along the same path. A ray on the principal axis is reflected along the same path. What is that? Hello, are you listening?
So, Mr. Come again.
Gideon, I'll beat you. Pay attention. A ray on the principal axis is reflected along the same path. Okay, by a mirror. What is the angle between the reflected ray and the normal? I'm taking it again. Listen attentively. A ray on the principal axis is reflected along the same path. What is the angle between the reflected ray and the normal? Hey, Joel. Joel, what's your answer? Okay, Joel was just testing his microphone. Yes, a ray on the principal axis is reflected along the same path. What is the angle between the reflected ray and the normal? Yes. Who is ready? Oh, let me hear from you. Angie.
That is 0.
Angie, what's your answer?
So I was thinking 0.
Okay, that is Angie's view. Gideon. Gideon. Okay, Kingsley.
Say 90 degrees.
Kingsley is going for 90. Yasmin.
45 degrees.
Yasmin is going for 45 degrees. Isabella.
90 degrees.
90 degrees by Isabella. Augustine, are you there? Anita.
Sir, please, I think it's 90 degrees.
Anita is going for 90. Gideon, your hand is up, but you will not talk. What is your secret? Gideon. Okay, I'm just giving a sketch. Janelle, are you there? Janelle. Janelle is quiet. Okay, so let's see. So a ray on the Francis. A ray on the principal axis is reflected along the same path. So assuming this is the incident, it will be reflected back along the same path. Ablina, are you there? Ablina,
Yes.
what's your answer?
Sir, please, 90 degrees.
90. Francis.
Simply 0.
Francis is going
0
for
degrees.
0. 0. Okay, so now, on what condition will the reflected ray be reflected along the same path? On
When
what
it's 90 degrees,
when
they strikes the mirror at 90 degrees.
exactly? So it means the mirror is perpendicular to, the ray is perpendicular to the mirror. That is the only condition where it will reflect back. Now, it means that whenever you are incidenting a ray, there must be a normal. So, and the normal is always perpendicular to the mirror. So if we have this, then it means the normal would also be along that same path because it must be perpendicular. It must make an angle of 90 with the mirror. So the normal and then the incident ray, the reflected ray are along that same path. Okay, so that is what I've drawn. By this, it means that the angle between the reflected ray and the normal must be 0. They are parallel, they are along, you see, one lies on the other. The incident ray, the reflected ray, and then the normal, they are all lying on one another. And meaning there's no angle between them. So the angle here, theta must be 0. So what's the angle between the reflected ray and the normal? Is 0. The 90 comes in when we are looking at the reflected ray and the mirror. But for the normal and the reflected ray, the angle is 0. Class, are you okay? Are we okay?
Yes.
Yes, please.
Okay, another question. A ray of light strikes a plane mirror at an angle of incidence equal to 35 degrees. A ray of light strikes a plane mirror at an angle of incidence equal to 35 degrees. Please, I will expect answer as soon as I end this question. Anita, this is your question. A ray of light strikes a plane mirror at an angle of incidence equal to 35 degrees. The angle between the incident ray and the reflected ray is, Anita, what's your answer? The angle between the incident ray and the reflected ray is. Hey, Anita, you are delaying, oh.
So please can you repeat the question again?
I won't repeat.
I
Yasmin,
didn't
what?
hear the ending.
Okay, Yasmin, what's your answer?
Said 35. So please, did you say 36 or 35 degrees?
I said 35. Okay, Gideon, what's your answer? Oh, how I expected you.
Sir, please, 70.
The answer is 70.
70.
How? But honestly, I was expecting you
Yes, sir.
to have paid rapt attention so that as soon as the question ends, you respond. Okay. So a ray on the a ray of light strikes a plane mirror at an angle of incidence equal to 35 degrees. Okay, the angle between the incident ray and the reflected ray is 2 times 35, so 70. When a student looks into a plane mirror, she sees a virtual image of herself. However, when she looks on a sheet of paper, no such image is formed. Which light phenomenon accounts for this? I'm repeating the question. When a student looks into a plane mirror, she sees a virtual image of herself. However, when she looks on a sheet of paper, no such image is formed. Which light phenomenon accounts for this? Frank?
Reflection of light.
The emphasis is on the latter information. The emphasis is on the latter information. And what's the latter information? Listen. When a student looks into a plane mirror, she sees a virtual image of herself. However, when she looks on a sheet of paper, no such image is formed. Which light phenomenon accounts for this? Yes.
So please, absorption of light.
No. When she sees or looks at herself on a sheet of paper, no such image is formed. Which light phenomenon accounts for this? Okay, listen. There are possible.
Dispersion of light.
Come again.
Dispersion of light.
Basira, sorry. No. Gideon.
So the refraction of light.
No. Saki.
The rectilinear propagation of light.
No. Okay, listen to There is Anna Abinema. Anobu, I'm listening. Oh, it gets so worrying if a student raise their hand and cannot speak. Saki.
Sir, can I take the question?
I won't take the question. Anita.
Sir, please, the light scatters.
The light scatters. Don't you? Then that is, listen to the possible answers. A, regular reflection. B, diffuse reflection. C, polarization of light. And D, resonance. We cannot see ourselves, our images on the floor or ground because the light scatters or diffuses. Okay, we have regular reflection and scattered or diffused reflection. We cannot see ourselves, our image on paper because the light scatters. The surface is so rough that the incident beam is scattered or is dispersed or diffused. So that is what the phenomenon of light which accounts for that. All right, so class, if you don't have any question, we'll end here. If you have a question, quickly ask. We have about 2 minutes to go. Is there any question? All right, if there's no question, then this is where we end the show for today. As I promised, there will be another final session, which will certainly be on Friday. Friday, it's not possible because physics students will be writing practicals on Friday. So Saturday, okay? All right, so until then, may the good Lord be with you. Take care of yourselves and bye-bye to all of you.
Bye. Same to you, sir.
All right, okay.
Bye-bye.
Bye-bye.
Boy.
Bye, Kennedy.